In module 2, I'm going to introduce to SolidWorks. Under this, we are going to cover the interface and fundamental of SolidWorks. Then I'll teach you how to start part, assembly and drawing environment. Then we'll introduce to the various SolidWorks document. Then I walk you through the shortcuts, customization of CommandManager, and lastly, the working with the mouse gestures. Now, out of this, the fundamental of SolidWorks is very important. So I want you to pay very close attention on that part. Before that, you must have a SolidWorks at your place. I will provide the Google Drive link so you can download this software. Now, mind well, it's basically 16 gigabyte of setup file. So it's requires some time. Before that, you must check out the system requirement. Now, SolidWorks do not provide a free license to students. They have to buy it. Now, when you open the SolidWorks first time, you may be asked like this kind of a dialog box where you have to choose the units and its dimension standards based on your working style. Once you complete it, whenever you open any part file or assembly file, their units will be simply taken from this chosen value. So it is only asked first time. Now when you open the SolidWorks, you may see like screen like this. Now here it is home button. When you press it, it will display this kind of dialog box. Even when you open the SolidWorks, it will also prompt with this dialog. Now here on a home tab, you can simply create new part file, assembly file and drawing files, or you can open the existing file. Just below new, you'll see the recent document open. Now the purpose is you can just continue from the last project. It is also provided separately over here. If you have a number of documents opened in the last time, you can also explore the folders from here. So home tab will provide a basic startup step. Now let's try to create a new document. Now on this, you will see this is new document icon. If you click over here, you'll find the same thing, right? When I press on this, it will present me new SolidWorks document dialog box. From this location, you can either create new part file, either create assembly file, or either you can create the drawing files. Now in your company, if you have to use your customized template, then go for advanced. There you can find the template you have simply brought over here. Now how to add this tab over here so you can use your customized template, I'll show you later. Now let's go back to the front side. Now here I have chosen the part file, so click it and press OK. Now I have created the part file 1 where name is given part 1. Now here, this part, if I just go over here, this small triangle, now it is auto collapse. If I want it, just I pin it up. So this is called the menu bar. It is like a other Windows program where you can have a creating new file. You just can open the file, close, save as, print. Similarly, edit menu, view menu, where you can control the display of various tools like insert, right? In insert, you can find the features, surfaces, sheet metal, everything. And under the tools, you can simply have equations, sketch entity, and other options. So this is standard menu bar. Now near to that, you can see over here, it is simply a standard toolbar where you can simply create new file, open the existing file, save as, print. You can also have a file properties and options. Let me draw something so you can understand over here. Look at very carefully. This part is known as CommandManager. Now CommandManager offer various tools related to these tabs. For example, if I click on sketch, I'll be offered the various drawing tools like lines, circles, rectangles. Similarly, we have a evaluate CommandManager, MBD dimensions. You can add more. If you want to, just right click on this and go to tab and you can add, let's say, surfaces. So surfaces command manager is available. So command manager provides access to different SolidWorks tools. There are various command managers such as features, sketch, evaluate, and so on. Now if you look at on this left side over here, it is referred as FeatureManager Design Tree, where you can see the entire process, or you can see the feature used to build the parts. At this present moment, I have only used one feature called extrude. I can add more if you wish to. Let's say add radius of 2 mm over here. So I have added two features. So it keep record of all features used in creating the model. Now let's say I want to edit these features, extrude features, right? Right click and edit. Now this is referred as property manager. On the left side it was FeatureManager Design Tree. This is property manager. Now this property manager will help you to edit the various settings related to the features. Now over here, this is referred as Heads-up toolbar, where you can zoom the model, you can zoom the specific area of a model, right? You can you can take the section of a model, right? You can also view cube, where you can simply set the top view, or you can say, let's say, right hand view. So all these display related features available on this Heads-up toolbar. You can also control the display of axis, triad, right, dimensions, geometric relationship, and the axes. So here you can simply have a complete control of what to display on a graphics area. So this part is referred as graphics area. And lastly, this is called triad. A triad will give you an idea how you are moving in 3D space. For example, this is XY plane, this is ZX plane, and ZY plane. So it helps you to locate the orientation of a model. On the right side, if you click over here, it is called SolidWorks resources, right? And they are grouped together. You can access various features. For example, library, you can open the documents over here from your workstations. You can also create drawings. You can also control the appearance of a models, and you can create the custom properties. So if you click over here, it is simply auto collapse. Now let's discuss the fundamental of SolidWorks. Parts are the basic building blocks in the SolidWorks. Now assembly contain parts or other assembly called subassembly. SolidWorks model consists of 3D geometry that define its edges, faces, and surfaces. Let's say you want to create a block like this. So first you need to draw the rectangle, okay, which is a geometry, and then you have to extrude in vertical direction. So in SolidWorks, the sketching is very important. You have to use your 2D geometry to create the 3D solid model. SolidWorks software lets you design model very quickly and precisely. Other benefits of SolidWorks that you can change your model at any time, and it is bi-directional associative, means any change you made in drawing document will reflected in 3D parts. If you make some changes in 3D, its drawings which is connected with this part also get updated. SolidWorks uses 3D design approach. As you design a part from initial sketch to final result, you create a 3D model. So as we learned earlier, that in a feature design manager tree, you add feature one by ones. So from this model, you can create 2D drawings or made component consisting of parts and subassembly to create the 3D assembly. You can also create 2D drawings from 3D assemblies, right? So SolidWorks will help you to create 3D parts, assemblies, and drawings which are interconnected. They are having bi-directional associativity. Now before you design any part in SolidWorks, you must know what is a concept of design intent. Intent means intentions. Design intent determines how you want your model to react as a result of changes you need to make to the model. So design intent is primarily about planning. I'll discuss what exactly it means. How you create the model determines how the changes affect. This is very important. Okay. And this is what it makes the design intent. The closer your design implementation is to your design intent, the greater the integrity of the model. Now let's discuss the design intent. Now let's try to understand it again through example. Here there is a one block. Exactly in the center there is a cylindrical features with the hole. Now what is the intention over here? This hole, small hole, must remain in center of this circular features. In the second stage, I have changed the location of these cylindrical features, not the hole. So here the hole remain, it moves with the cylindrical feature, means it tried to remain in the center. So here design intention is achieved. But on third stage, I would say, when the cylindrical feature has moved, but the hole remain over there. So there is simply eccentricity over here. So design intent is not maintained. So how can we include the design intent? So the sketches. So sketches is very important. So design intents begin with the 2D sketches in the environment. So before you actually design the model, it is help to plan out a method of how to create a model. After you identify needs and isolate appropriate concept, you can develop the model. Now in the design methods, the first part is sketches. Create the sketches and decide how to dimension and where to apply relation or constraint. This is very important. If you make mistake over here, your model will not behave the way you expected. So design intent will not meet. Now in second, features. Select the appropriate features such as extrude, fillets, and determine the best feature to apply and decide in what order to apply. This is very important. Sometimes what happened when you use, let's say, extrude cut feature first, then you apply the fillet and then you go for cell. So because of this order, you may not get the model outcome the way you expected. So you have to reorder this use of features. That's what it explained over here. In the case of assembly, select the component to mate and then apply the types of mate to finish this assembly. So a model almost always include one or more sketches. This is really important statement, right? Any model you make will have one or at least more than one sketches and one or more features. This is also true. Not all models have, however, include the assembly. Now let's try to understand the design intent in actions. So click on a new file, part, and OK. Now the units are in millimeter. If you wish, you can change from here other unit system. Now I'll go with the default file, default units. Now choose front plane and click on sketch. Now do not worry right now. I have not teach you the various tools, but my intention is to teach you the concepts. So let's go for rectangle tool over here and select. Now let me dimensions. It is 100. And let me take this is 50. Okay. And let's extrude over here. Okay. And this time I'm going to take it 10. Now I want to create a whole feature over here. So select this surface and click on sketch. Select the circle over here. Now let's go for smart dimensions. This is just a demonstration, nothing else. Okay. Now I know this is 100 and this is 50. So this distance of hole will be 50. Okay. And from here, this is going to be 25. Okay. Now let's go features and let me cut the materials. So here I'm going for through hole and click OK. So I have a part file exactly, the hole exactly in the center. Now let's say I have a change in the model. So double click the sketch, it will display your dimensions, sketch dimension. Now let me make it 80. Okay. And let me make this 40. Now let me rebuild. Now the problem is earlier, based on the dimension of 150, the hole seems to be in the center of the plate. But as I have changed the dimension from 100 to 80 and 50 to 40, you can see the hole looks like shifted to somewhere else rather than remain in the center. So here my design intention has failed. Now how can I correct these things? So let's go over here and edit the whole sketch. Instead of giving dimensions, let me delete this part. Now I have various methods to achieve that things. So I will use center line and I will take this corner to this corner. Okay. And I will move center of a circle on the midpoint of this diagonal line. So I will choose midpoint and control and click this and I will go for coincident, right? Now let's exit. Now let's again try to change the dimensions. This time I'm going to make it 150. Okay. And this time I'm going to make it 100. Now let's rebuild. Now see, even though dimension has changed, the hole remain in center. How it happened? Because I have drawn a reference line, center line over here. So on the midpoint of the center line, I have assigned this circle. So as this corner changes, obviously length of center line changes and also its midpoint. So on that midpoint, circle remain over there. So with respect to change in dimension of width and height of a plate, the hole remain in center, right? Let's say I want to change the dimensions from 15 to 50. So let's rebuild. Okay. Look at this. Okay. So this is how you can achieve the design intent. Now another way is to give the equations. Now let's remove these features and circle as well. Now another way is, now edit this sketch one. Now let me put circle over here and its diameter would be 30. Okay. Now this time, instead of giving the half of this dimension, I will create an equations over here. So is equal to these dimensions divided by 2. Click OK. Similarly, from here to here, I will connect this height by selecting these dimensions divided by 2. So this way I have created the equations. Now the center location of this hole will be governed by this equation. Now this equation is connected with the dimension of this sketch. Now let's try to change this from 150 to 100. Okay. And from this 100 to 80. Okay. Let's rebuild. This is another way to achieve the design intentions. Now feature-based parametric modeling is one of the important aspect of a SolidWorks. Parametric modeling automates the design and revision procedure by the use of parametric features. So dimensions, which control the size of geometry, and the geometric relationship, perpendicular, parallel, coincident, angular. These together will control the entire model geometry. So parametric means that the geometry definition of a design such as dimensions can be varied at any time. Earlier we have seen that I have changed dimension from 100 to 80, 80 to 150, and even though the model updates according to and our design intent achieved. So It is basically allowed to change during the design processes. Now feature-based modeling, where feature-based modeling means that you can build the model by creating 2D sketches and applying processes. Processes means features to create the 3D shape. Now let's try to understand from this figure. Here I have built one model. So where this is our first features, then we have used reference sketch, reference plane, another second features, cut feature which is third, fillet and cut. So we have used almost 5 features to build this model. Let's try to create one model. Now click on this new and let's start the part document file. Now here I will use the inch dimensions or inch unit. Now let's say rectangle tool over here. Dimension would be 2.5, 4, and let's extrude. Okay, this time we'll extrude by 0.5 and click OK. Now on this top, let me create one more sketch. This time I will use this line. Then I will draw one more line. I'll go back to the sketch again. And then I'll complete the sketch. Now here, I'm going to provide dimension over here. But because this 1.25 is already equal to this line. So we are not able to add the dimensions, a driven type of dimensions. Instead, let's try to control this one. So 1. Okay. Now let's extrude. Go to features and extrude. Again 0.5 dimensions. Now click on this. This time I will add a circle. Okay, whose diameter is 0.5. Now let's go to features and extrude cut. Okay, so if you look at very carefully on the left side on Feature Design Manager tree, so I have this boss as a first features, this second features and third features. Now let's say I want to change the dimension of this hole. So just choose it, select it and double click it and make it 1 and rebuild it. So it will reflect the changes immediately, right? Let's say I want to click this and I want to from 4 to I want to make it 3. So this is how the model reflects. So this is called parametric modeling. We are using the geometry and dimensions and features. We can build a robust model which reflect the changes. Now, how can you create a part file, assembly file and drawing file? So when you click on this new SolidWorks document icon, it will present you this window, dialog box, new SolidWorks document. So you can create part, assembly and drawing. Choose whichever you want to create and click OK. Now, in part environment, we have to use various features to build the part along with the appropriate sketches. So in part environment, we can use features CommandManager where various features are available like extrude, boss, revolve, loft. And similarly, these features add material and anything just having a word written cut will simply remove the material. This is called graphics area. This is Feature Design Manager tree. Similarly, if you click on assembly, this is the view of assembly environment where you have to add the parts by browsing the relative directories. Once you keep adding the parts and giving the various mates, you are able to create the assembly. For example, over I have created knuckle joints where I have added the fork ends, then single eye, knuckle pin, then the collar and taper pin. And in case of drawing environment, if you choose this drawing environment, you are able to create 2D drawings from the model. So first, How it is different? Here in Command Manager, the commands related to create a 2D drawings are offered. For example, you have to add the model views, front view, side view, top view. Then you have to go for adding the annotations. You can also create the projected views, sectional views, detail views. So these all things are available in drawing environment only. Now what is beautiful thing about SolidWorks is if you change any dimension over here, it will update the model geometry as well. Now what are the different SolidWorks documents? When you create the part, it is saved as .sld part. SLD means SolidWorks part file. So this extension is for SolidWorks part file. Similarly, SLD.SLD ASM. So it is stand for SolidWorks assembly file type. SLD DAW is for SolidWorks drawing file. Now here .PRT.DOT means it is part document template. Now what is template? Template is basically a drawing file which has some settings already loaded. So you can reuse them again and again, and that will save your time. Similarly, we have assembly template. So you can define the units and other settings in part template. So you don't have to do again and again. Now for the drawing template, we have DRW.DOT, and lastly SLD.DRT, which is called drawing sheet format. Now let me put in simple word, it is title block. This is title block, which can be saved as a separate file with these extensions. Now to work efficiently in SolidWorks, every time you do not have to go to Command Manager and you have to start or invoke the commands. So this will surely increase your mouse travel and will fatigue your muscles. So shortcut menu is very helpful in SolidWorks to carry out the same work with a shorter mouse travel. So invoking shortcut menu will help you to achieve many functions very quickly. So it is invoke when you right click on a graphic area. It is context sensitive. If you are in a sketch environment, they will offer sketch related shortcuts in this right click menu. So it provides quick access to the most frequently tools. You can customize this context sensitive toolbar by adding the tools to them. You can customize the command manager. All the tools are simply put in a different category. Let's say here it is feature command manager. If you want to access the sketch tool, then you have to go for sketch command manager, then for surfaces. Every time you have to click and switch between these two managers. So what you can do, if you are using very specific tools for creating the model, you can place all these features in a single feature command manager. So you can add them by customizing. So you can add the tools of your choice. So right click on command manager and invoke the customization option and add them. Now you can also use shortcut. Let's say press S key to invoke the shortcut toolbars. This is available in Sketcher environment, part environment, and the other modules. Okay. So this is the simply screenshot of a same thing. We'll see entire thing in actions. Now mouse gestures act as a shortcut to quickly access the frequently used tools only. Now what does it mean? Let's say you are using circle, lines and rectangle frequently in sketch environment. Then you can add them to a gesture wheel like this: line, rectangle, circle and dimensions, right? So to display the mouse gesture, you have to press and hold the right button on the mouse and then you have to move. So you can select the related tools. Let's say for you want to choose the line, just move left side by right clicking the right mouse button in a graphic area. So all these mouse gestures are available in all environment: part, assembly, drawing and sketch environment. Now let's try to see all these keyboard shortcuts and mouse gestures in actions. So let me open the new part file. Now I have nothing on the screen. If I right click, I can have a zoom to fit, area, zoom out, pan, roll, all this which is available on View Heads-up toolbar. The moment I start the sketching, let's say I have drawn a small rectangle. If I right click, so I'll be offered tools related to the sketch. I can draw the lines, circles, splines, all these are available over here. So this will help me to choose the drawing entities very quickly, right? If I want to delete something, I can delete as well. Now let's say I want to customize this command manager. So right click and select the customize. Now here, go to command. Now I will search something like, let's say, mass property. I need it. I use them very frequently. So click and put it over here, right? Similarly, let's say you want to add like an ellipse tool. So pick and drag, or let's say weld maintain. Click and drag it over here and click OK. So they are available over here. So you can quickly use them instead of going to the respective command manager. So this way you can customize. Again, right click, customize. Now let me draw a small figure. Here I have a rectangle. Okay. Now I want to draw the circles. So I would like to use mouse gesture. So right click and slide on the right side. See the wheel is appear. So I will choose this circle like this. Okay. Now right click. I want to dimension. So I will move up. So I will have a dimension tool. Okay. Now let me exit. Right click again, customize. Now go to mouse gestures. So here I can say I want to add arc. So I want to simply add arc over here instead of line, right? So whenever I'll be working in sketch environment, and if I right click and move left side, the arc will be available to me. Similarly, if you want to add features to part, let's say I want to add extrude. Just pick and drop over here, right? I want extrude cut, so make it over here. I want, let's say, revolve. Pick and over here, right? Now let's try to use this mouse gestures. Okay. Now let's try to create one more part file. This time circle. Now I am in sketching environment. I have to go to the features and then I have to choose this extrude or revolve features. Now instead of going over there, I will press S key. So this is called shortcut menu. Here, because I am in sketcher environment, the tools related to the sketching is offered. Now I want to add over here my extrude features. So right click, customize. Now here I will type extrude and I will drag over here. Okay. Let's say I don't want trim, so I will drag it back. Okay. So I have added this extrude features. So let me click OK. Now let me press S key. So extrude is available. So instead of going over there and invoking the features, extrude features, I can start over here. So this way S key is very helpful, right? Now let me press it again, S key. Now here this is again context sensitive. I am in feature environment, so it is offering me the other various tools, right? I can also customize them. Right click, customize. Again, right click, fillet. Just give the value, okay, and fillet out it. Okay. So this way it is very helpful. Now let's use the mouse gestures. If I right click and move, I'll be invoking the extrude tool as I've customized earlier. Let me press escape. If I right click and move on this left side, it is extrude cut. Okay. So let me draw one more sketch. This time I'm going to add rectangle like this. Now press escape and I will use S key to extrude it and click OK. Right. Now let's say I want to draw one more sketch on this like this. Exit from the sketch, press escape key and extrude cut. I will choose this part and I will remove the materials. Okay, like this. So you can use mouse gesture to access the frequently used tools in various environment.